All right, let's take a look at some more graphing of quadratic relations. Now, I am going to also go over how to find the x-intercepts in this video. I do have a separate video on how to find x-intercepts, so this one is going to be my official notes for our final section in our quadratic functions adventure here. So, the y-intercept of any quadratic is always on the y-axis, of course. So it's over 0, up something. So you can just plug in x equals 0 to find that, to figure out what y would equal. And we'll do an example here down below in a moment. Additionally, by the way, it's also the c value. We talked about that previously in class, I believe. Now, we haven't talked about x-intercepts. X-intercepts are going to be over something up 0. So this is when y is 0. So how could we figure that out? Well, we're going to factor the function into factored form. So for example, we might have x plus, I'm going to use different letters other than A, B, and C just to avoid any confusion. Let's use f and x plus g. And then what we do is we're going to set it equal to 0 to figure out what causes the function to spit out 0. Because that right side is kind of our y equals. That's our y number. That's our output. So this might be easier once we look at an example. Now let's first look at standard form, ax squared plus bx plus c. You've been working with the quadratic formula. Earlier in the chapter, I bet you solved quadratic equations that were already set equal to 0. So to find the y-intercept, it's really easy. You can plug 0 in there and get y equals 0 squared minus 0 minus 6. Oh, and of course, y equals negative 6. Or it's just the c value. C equals negative 6. So we go to our y-axis, and we go down. There's 3, 4, 5, 6. All right, this is our y-intercept. We got that from part A in this. Okay, so in standard form, that comes from the c value. That was easy. Now, what about the x-intercepts? So we could do this graphically, but I'm just going to jump right to algebra, okay? We're going to find the x-intercepts. So write this down carefully, listen carefully. Here we go. You ready? So y equals x squared minus x minus 6. We're going to factor. Y equals x minus 3, x plus 2. All I did was reverse FOIL there, okay? And now I am going to set it equal to 0. And you remember earlier when you were solving quadratic equations and it's set equal to 0, what do? You just set each factor to 0. So x minus 3 could be 0, or x plus 2 could be 0 is another solution. So if I add 3 to both sides, you see x equals 3 and x equals negative 2. These are the x-intercepts. It is where y is 0. So we have two of them. We have 3, 0 and negative 2, 0. 3, 0, negative 2, 0. Now I'm starting to get a good visualization of this because the axis of symmetry would be right in the middle of these two. It would be directly in the middle. Let me repeat that. The axis of symmetry would be right in the middle. Now you might be wondering, why am I drawing it at 0.5? Because that's where the middle of 3 and negative 2 is. How do you find that? You could take 3, you could average them. 3 plus negative 2 and divide by 2. that is 1/2. So the axis of symmetry is x equals 1/2. Now I can start sort of using the axis of symmetry to my advantage here and mirroring it across. Now, if you've had me in class or saw some of my other videos, you know that I talk about the 1, 1, 2, 4, 3, 9 trick, because on a standard x squared graph, it goes through 0, 0, and then 1 squared is 1, 2 squared is 4, 3 squared is 9. So if you start at the vertex here, you would then go over 1, up 1 to get another dot, over 2, up 4 to get another dot, and so on. All right, so if you want to figure out the vertex here, you would plug 1/2 through the function and see what comes out. I'm not super worried about that in this problem. All right, we were able to get a pretty quick sketch of this thanks to the y-intercept and especially thanks to the x-intercepts. They were very helpful there. All right, let's talk about the other form that we have here that we've been working with some, and that is vertex form. Vertex form is where the vertex is at HK. You don't have to do any calculating at all. It's just staring at you. Whatever number is after the minus sign, that's your x coordinate. Whatever number's at the end, that's your y coordinate for your vertex. You don't have to deal with opposite of b over 2a or any of that stuff. So as I'm looking at this example here, I would say that the vertex is at 2, 9. So I'm going to go over 2 and I'm going to go up 9, which is all the way up here. All right, and then I know that the axis of symmetry is in the middle of the graph. Okay, so I know that this thing opens down as well because the minus sign in the front. So I know it's a U-shaped like this. Now we're going to find the y-intercept here. How could we find that from vertex form? We would have to use FOIL to figure out that, because I'm wondering c equals question mark. See, there is no c in this. We had to figure it out. So y equals negative x minus 2 squared plus 9. That's negative x squared minus 4x plus 4 plus 9. That's negative x squared plus 4x minus 4 plus 9. And then I combine these two and I get 5. Aha! That's my c value. So I could go up 5 and put a dot on here. So I had to figure out the c value by doing a little bit of FOIL there, or box method if you prefer, and then distributing the minus sign. That's what I did here. I distributed the minus sign, and at the very end I rolled that 9 in with the negative 4 to figure out the y-intercept. Now thankfully it's a 2-for-1 deal. I can mirror that across, and notice over 2 down 4, over 2 down 4. That's that 1, 1, 2, 4, 3, 9 trick that I talked about. So we could go over 1, down 1, and fill in those dots. Now this question is asking to find the x-intercepts also. And I'm just going to focus on the algebra because, you know, anyone can go to Desmos, type it in, and figure out graphically. So how do you do that algebraically? Well, we have to go here, okay, and we have negative x squared plus 4x plus 5. We set that equal to 0. And then we solve it. We solve the equation. Now the first thing I'm going to do is divide both sides by negative 1. I'm going to change all the signs. That's a legal move. You're allowed to do that, and sometimes it's really helpful if you just change all the signs. So then I factor x minus 5, and I've got bazillions of factoring videos on my channel, so check those out. All right, so I factored it, so I know that x equals 5 is a solution to this equation, and x equals -1. That means we have two x-intercepts. They would be over 5 up 0 and over -1 up 0. All right, 1, 2, 3, 4, 5, there it is. And if you check with that little trick that I talked about, 1, 1, 2, 4, 3, 9, puts us right there. Actually, those are our x-intercepts. So we get this graph going down just like that. All right, so what was new here, I guess, in this section was I really spent a little bit more time on finding those x-intercepts. I also had to convert from one form to another so that I could find the c value, which gave me my 2-for-1 deal here. And then, of course, from vertex form, you've seen this before. From vertex form, you can harvest out the vertex, and that's really helpful as well. All right, hopefully this video was useful for you, and now you're just an expert at solving quadratic functions. All right, until next time.